we're going to explore how a 26-year-old patent clerk literally shattered our fundamental understanding of reality. Welcome to our journey through the physics of time. Today, we're looking at a true clash of titans, Isaac Newton versus Albert Einstein. And honestly, we are going to completely tear down what you think you know about that ticking clock on your wrist.
Now, what's really fascinating about this question is how it completely messes with our basic, everyday intuition. Just think about your own life for a second. You wake up, you go to work, you sync up your calendar with colleagues across the globe. You just naturally assume that a second for you is a second for someone in Tokyo or on the moon or anywhere else in the cosmos. I mean, it just feels right, doesn't it?
Picture this. You've got a ticking clock sitting right next to you on a gorgeous, calm sunset beach. Now imagine another perfectly identical clock flying through deep space inside some highly advanced spacecraft. Common sense tells us that a second is a second, everywhere. A minute is a minute. If you check both of those clocks after what feels like an hour, they should both read exactly 1 hour later. And you know, for centuries, all of humanity, including our greatest scientists, believed exactly that.
Section 1. Universal Master Clock. Newton's Absolute Time.
So back in 1667, Isaac Newton drops his Principia, and he basically lays down the rules of the road for reality. He declares that absolute, true, and mathematical time flows uniformly without relation to anything external. What Newton is essentially saying here is that time is the ultimate, unchangeable metronome of the universe. Nobody gets special treatment. It's the same for all of us.
In this really comfortable framework we all grew up with, space is just an empty container. A big, fixed stage where stuff happens. And time is just a uniform flow that is completely unaffected by whether you're standing still, running a marathon, or caught in a massive gravitational pull. If Alice stays in New York and Bob travels to Tokyo for a year, they both age exactly 1 year. It's perfectly intuitive. And for over 200 years, absolutely no experiment contradicted this.
Section 2. The speed of light crack. A problem appears.
But then, in the 19th century, this massive crack shows up in Newton's perfect universal foundation. See, in everyday life, speeds just add up. If you're on a train doing 100 kilometers an hour, right, and you throw a ball forward at 20 kilometers an hour, someone standing outside sees that ball moving at 120. Makes total sense. But light? Light flat out refuses to behave like a normal object. If you're in a spacecraft moving at 90% the speed of light and you shine a flashlight forward, a ground observer does not see that light moving faster. They measure the light moving at exactly c, the speed of light. Its speed never, ever increases.
And the math here leads to a consequence that you literally cannot avoid. If you want to keep the speed of light constant for everyone, everywhere, no matter how fast they're moving, well, something else has got to give. Space and time themselves have to bend. They simply cannot be absolute. If the speed of light is the universal constant, then the ticking of a clock and the length of a meter stick must become flexible.
Section 3. Special Relativity. Personal Clocks.
And that brings us to 1905, when Albert Einstein steps up with a completely mind-bending solution. He realized, hey, there is no universal clock. Instead, every single object in the universe carries its own personal clock depending on its motion. He took the constancy of light as a pure fact and just followed the math. Because the laws of physics are exactly the same whether you're standing still or zooming along at a constant speed, space and time must dynamically adjust themselves to make sure the speed of light stays the same for you.
You can see this beautifully in his famous trained thought experiment. It shows us that the whole concept of things happening at the same time is completely broken. So, picture a ridiculously fast train. Lightning strikes the front and the back. To a guy standing on the platform, bam, they hit at the exact same moment. But the person riding inside the train, they're moving toward the front strike and away from the rear one. So to them, the front lightning hits before the rear. And here's the crazy part. They are both right. What you call now isn't some universal truth. It's just a fact about your own personal motion. The present is literally relative.
And listen, this isn't just some weird math trick or optical illusion. Take the famous twin scenario. Emma stays on Earth. Her twin brother Liam hops in a ship zooming off at about 86.6% the speed of light. For Emma, 20 years pass by. But because faster motion actually slows down personal time, Liam only experiences 10 years. The universe genuinely allows different amounts of time to pass. Liam literally returns to Earth 10 years younger than his twin sister. His clock didn't malfunction or anything. His path through space-time was just different.
Section 4. General Relativity.
gravity's effect.
Fast forward 10 years to 1915, and Einstein takes this whole thing a massive step further by bringing gravity into the picture. He realized gravity isn't some invisible magical tether pulling things together like Newton thought. Actually, as physicist John Wheeler brilliantly summed it up, mass tells space-time how to curve, and space-time tells mass how to move. Planets don't orbit the sun because they're being pulled. They orbit because the sun's massive weight creates a literal dent in the fabric of space and time. The planets are just rolling along the curved surface of that dent.
Now, because gravity is literally the warping of space-time itself, it inevitably warps time too. Basically, the stronger the gravitational field you're hanging out in, the slower your personal clock is going to run. Think about the extremes here. Out in deep space, far away from any planets, your clock runs at its absolute fastest. Down here on Earth's surface, it ticks slightly slower. Stand on a ridiculously dense neutron star, and your time slows down dramatically. Fall into a black hole where gravity is infinite, well, to an outside observer looking in, your time appears to freeze completely.
Section 5. Real-world proof, GPS, and relativity.
Okay, if all this sounds like abstract science fiction that has absolutely zero impact on your daily life, let's talk about the GPS satellites orbiting our planet right now. These things have to constantly battle conflicting math. Because they're 20,000 kilometers away from Earth, they experience weaker gravity, which means their clocks actually run faster by about 45.9 microseconds a day. But because they're zooming around the planet at 14,000 kilometers an hour, velocity time dilation kicks in, meaning their clocks should run slower by 7.2 microseconds. Combine them, and you get a net relativistic correction of 38.7 microseconds every single day that engineers literally have to actively account for.
So why does that actually matter to you? Well, if engineers didn't actively program Einstein's relativistic corrections into those satellites, that tiny little discrepancy would completely wreck your smartphone's navigation. You'd be off by 11.6 kilometers every single day. I mean, your Google Maps is living, breathing proof that time is relative.
Section 6. Newton versus Einstein, the final comparison.
All right, to wrap this whole thing up, it is absolutely vital to remember that Newton wasn't, wrong. His absolute framework, it's still perfectly accurate for everyday speeds and weak gravity. We still use Newton's exact equations to launch rockets, but Einstein revealed a much deeper, far weirder layer of reality. Time is relative. Space and time are dynamic. Gravity is curvature. Newton gave us a working universe, for sure, but Einstein gave us the true architecture of reality.
And that leaves us with a truly profound realization. Time is not something the universe shares. Time is something each traveler experiences. Right now, out there among billions of stars, billions of clocks are ticking at slightly different rates, each telling its own unique story. Which leaves us to wonder, what is your personal path through space-time telling you?